Let's get the show started. Hello, everyone. Thank you all for joining. Welcome to In Rhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at In Rhythm, and we have several awesome lightning talks lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on evolving technology trends in the industry that will keep you learning and growing in your career. And this week, William Kingsley, who recently joined us as a senior Android engineer, will go over what Jetpack Compose is and then how it compares to XML. As a lot of you know, declarative UI is a mega trend. Both web and mobile are actively adopting this approach, and Jetpack Compose is Google's modern toolkit for building native Android UI. And I'm really interested in knowing how it's going to simplify and accelerate the UI development on Android. So without further ado, let's get it started, William.
All right, thank you for that, Parag. As Parag was saying, in this presentation, I'm going to be comparing and contrasting Jetpack Compose with the old view systems use of XML layouts for creating modern Android UI. So without further delay, let's get into it. So before we can compare and contrast Jetpack Compose and the old view systems use of XML layouts, we first need to understand how XML layouts are used within Android in the old legacy view system. So to provide a brief history of XML in Android, XML layouts are used by the view system for the purposes of rendering UI for Android applications. A thing you need to know about the old view system, about its use of XML, is that the view system is actually very, very old. It's been used effectively since the inception of the Android operating system, and it's been well over 10 years since Android became a mainline mobile OS. Android devs have historically had to update XML views by imperatively updating the internal state of UI components. And updating these components tends to be very, very error prone, as it is very, very easy to mistakenly assign a UI component an incorrect piece of data, maybe a mistaken data type that you did not intend to assign it. And so a question we might ask ourselves, with the invention of Jetpack Compose and with XML slowly being phased out of the Android platform, what is the future of XML and what does it look like for the view system? Well, the thing you need to understand is the view system, because it's so old and has been a part of the Android platform for so long, it's very, very stable and mature. And because of that, this will likely result in the view system being continued to be used in a lot of legacy Android applications, older applications, and also in some cases where your client, whoever it is that you may be developing an application for, may prefer a more stable UI system that is used in their applications. Many large applications will continue to use and will need to be maintained with the view system. And Google has also said that they will be continuing to support the view system for the indefinite future. There's not yet any scheduled time that I'm aware of in which the view system will become deprecated anytime soon. So how does the view system and XML layouts work? Well, the UI of an Android app is represented as a tree of UI widgets. In the view system, widgets are of view type objects. View objects are combined into groups to form hierarchical UI trees, and these groups are also known as view groups. And a view group is really nothing more than a collection or an arrangement or a combination of view type objects. XML layouts are therefore arrangements of view types that define the UI structure for a screen or for the entire Android application. To update the UI, the internal state of view components needs to be updated in order for that component to be redrawn on the screen. The process of updating the internal state of the view component must be accomplished manually. And we'll see an example of that shortly in a live demonstration that I will be doing of an application that I actually built for the purpose of comparing and contrasting XML layouts and Jetpack Compose. We can see in a brief example at the bottom of this slide, a text view object being acquired from the UI tree by walking it using the find view by ID function, and then the internal state of that text field being changed. In this instance, we're assigning it a string value of hello world. So what's the problem with XML layouts? Well, as I said before, updating the internal state of view components is rather error prone. XML layouts additionally require supporting components for certain more advanced or more complicated layout types, such as lists, for example. Lists in XML layouts require additional components such as adapters in order for that list to be rendered to the screen. There's often tight coupling between layouts and their respective activities and fragments, which can lead to spaghetti code within your activities and fragments that you define for the screens of your application. Creating custom view components can also be very, very challenging. This is especially true if you need to make custom shape objects or you need any type of shape that is not inherently defined or supported within the view system. This can make creating custom views quite challenging and very code intensive. Extra codes needs to be written for supporting components, as I've said before, for many of these more complex views. Large applications using layout files often become very, very difficult to manage, as you typically will have a single directory that stores all of your XML layout files. And when you have a single directory storing so many layout files, managing those layout files can become very, very tricky. Oftentimes you need to employ a standard naming convention in order to make sense of what a particular layout file should be used for or where it's used. And as you can imagine, even with a good naming scheme for layout files, it can be very, very challenging to manage all of those files, especially for a large application. Oftentimes, separate XML files need to be created for specific instances of customization. So for example, if you wanted to round the corners of a view, you would probably have to define an XML shape object that would allow you to round the corners of maybe a card, maybe a linear layout. Additionally, if you want to create some type of selectors or menu items, each of those need to also be created as their own XML files. So using XML, while it is a very, very mature solution for creating UI with a view system, it's a bit clunky compared to the modern alternative. So this is where Google has introduced Jetpack Compose. Compose solves many of the challenges that XML layouts present for Android developers. Well, what is Compose? Well, Compose is a modern declarative UI toolkit. Views are designed in a declarative way to respond to state changes or to data changes and to be redrawn to the view in response to those changes. Compose is compact with powerful tooling that we'll get into in just a moment, and is syntactically, semantically, and conceptually very, very similar to Swift UI, making it very, very easy for Swift UI developers or Compose developers to move from the Android platform or Google platforms, respectively, without too many difficulties. So why Jetpack Compose? Overall, it simplifies and accelerates UI development. Android developers can write significantly less code, as I will show in just a moment. The APIs for Compose are very, very intuitive. Most composable functions are called something as simple as card, column, row, and more often than not, these APIs are self-describing in that a column just represents a form of linear layout, and all of the items of that column or composable will be laid out in a vertical linear fashion. Compose also comes with built-in support for material design. This is a great benefit for developers because you no longer need to have to spend a lot of time playing around with or adjusting XML files that define the theme of your application. It also has superior tooling support compared to its XML counterpart. Google's done a really, really great job creating tooling right from the get-go for Compose. So what tooling exists for Android Jetpack Compose? Well, for starters, there's the Compose preview panel, as you can see on the left-hand side of this particular slide. This is great because this preview comes with a load of inspection tools and is also interactable. Jetpack Compose also comes with better layout inspectors, and it comes with a very, very neat and unique animation preview that allows you to inspect, execute, and debug animations for your Android applications, providing you a little better customization and handling of applications throughout your application. There's additionally gutter icons and features that are nothing more than just additional features that Google has provided in your editors for Compose development. Lately, Google has also developed the color pickle that is really, really fantastic for on-the-fly changing the colors in your Android application. It allows you to also quickly compare and contrast colors that you may be currently using in your application. Really a fantastic tool for developers. There's also the image resource picker, which is a new addition to the latest versions of Android Studio. And this allows for fast selection of image resources for something like an image composable or really any part of your application that might be handling or displaying images. Finally, there's the live editing of literals, which is a fairly new addition and allows you to, on the fly at runtime, while you may be inspecting a preview or a view of your Android application or even executing that application on an emulator, allows you to change the values of variables with simple types or built-in types. And you can change these literal values at runtime in order to change your UI. So behind the scenes, how does Jetpack Compose work? The way it works is very, very similar to React or Swift UI. Jetpack Compose responds to changes in data. The view hierarchy needs to be changes in data, and this results in the view hierarchy needing to be updated. Before Compose, this was accomplished by imperatively walking in the tree, as we saw previously with the find view by ID function on a previous slide. And when you have that view object for walking the tree, you then have to manually change the internal state of that particular widget. However, Compose is a declarative UI framework. The UI of a composable app is defined by a hierarchy of composable functions that describe the UI by emitting UI widgets. This is very different, though quite similar in comparison to the view system, where your UI hierarchy is composed of view objects opposed to composable functions. To respond to state changes, the UI is regenerated. However, this can be a bit of a costly process if you're needing to regenerate your UI in response to some data, especially data that may be changing very, very rapidly. To limit cost, Compose determines which composable functions need to be redrawn in response to state changes, a process that is known as recomposition. Composable functions are relatively stateless, do not expose setter or getter functions, and do not return data types, making them rather simplistic to create. So finally, in order to facilitate our comparing and contrasting of XML and Compose, I've created the JetNote application. The JetNote application is nothing more than a very, very simplistic note-taking application that makes use of the Room database for Android apps. So on the left-hand side is the XML version of the JetNote application, and on the right-hand side is the Compose version. Don't worry too much about making sense of any one particular line of code. These screenshots are going to be used more so for demonstrating the breadth of the code needed to create this application, and to the extent by which features of the view is coupled with the respective main activities. On the left side here, we can see that there's quite a few view components that we're walking the tree, the UI tree, to acquire in order to mutate or change the internal state of view objects, making up the view of the application. However, on the right, we can see that the application is composed of just a single composable function in the hierarchy. This makes Jetpack Compose much, much easier to read, maintain, and write for the developers of applications, simply because it has better separation of concerns. It requires less code in order to write, and the coupling between your view and main activity or fragment is significantly less than what we would have in the view system using XML layouts. So again, just to emphasize, don't worry about picking out or understanding any one particular line of code here. These images are just used for the purpose of examining the breadth and depth of the code necessary for creating this particular application. On the left side is the XML version of the application, and on the right is the Compose version. We can see that approximately 288 logical lines of code is required for creating this particular version of the application, including various supporting components, such as the adapter used in conjunction with the recycler view in order to display items in a list format. Whereas on the right side, we can see that really only two composable functions define the entire UI for the Compose version of the application. So now I'm going to go and pull up my Android Studio instances, and we're going to do in some live comparing and contrasting of these two versions of the Android application. So on the left side is the XML version, and on the right side is the Compose version of the JetNote application. Really quick here, we're going to demonstrate some functionality. I'm just going to show that this is in fact a working application. I'm going to create a new note. All right, and we can see that note added to our recycler view list in the emulator on the left side, and now on the right side. In the Compose version of this application, we can see that that note has been added to its respective lazy column list as well. I'm going to briefly hide the emulators from the screen, and let's take a look at some of this code here. As depicted in the screenshots, there's significantly less happening here in the main activity of the Compose version of the application. A lot less coupling of view components with the main activity as composed to its respective counterpart over here on the left in the XML version of the main activity. Notably, we can see that the Compose version is very, very scarce of requiring any references or instances of any of the Vue components for the application. Over here, in order to set, for example, a click listener on the Vue components of the XML version, I have to walk the UI tree and acquire the instance of the save button. And using that instance, I am then able to set a click listener for the button of the application, allowing us to save a note to the room database. We can also see here that there's additional setup required where I'm required to provide the recycler view, not only a layout manager defining the way in which elements are laid out on the recycler view, but also I need to provide it an adapter for displaying of the items contained within the list. That adapter can be seen in the note list adapter, defined here on the left. And we can see that this adds an additional 42 lines of code that I had to write, and 42 lines of code that are entirely missing from the Compose version, in addition to a view holder. And of course, the layout, the XML layout file for a note item in the list. Likewise, the XML layout file for the XML version of the application also consumes 126 lines of code itself, in addition to all these extra supporting files. And so we can see here why the Vue or XML version of the application consumes so much more code. These are so many additional features that we need to provide this application in order to get similar functionality that the Compose version provides us with relative ease. Nearly the entire application is composed of just a single file composed of just two composable functions: the note screen composable function and the note row, which defines a row or an item, a row item within our lazy column list for each item that's stored within the room database. This is all that's necessary, aside from the preview for rendering the preview of this particular screen in our handy preview pane for the application. This is all that's necessary for defining the Jetpack Compose version of the application. So to talk a little bit more about my experience in creating the JetNote application, what I found was Jetpack Compose was, excuse me, the Compose JetNote version of the application was significantly easier to create. This is largely due to the fact that it requires fewer lines of code for the developer to write in order to acquire similar functionality to its XML counterpart, thus accelerating build time of the application. The application's also simply because it has fewer lines of code, and the coupling between its main activity and its UI is significantly less, provides the application better readability and better maintainability over time. There's fewer components and fewer items thus needed to memorize and understand in order to comprehend and construct the application. There's overall better features for customizing composable functions, such as the modifier class that most composable functions will consume, and that modifier class will thus mutate or change composable layouts in the way in which developers desire it. Sharing composable functions and pieces of UI components is also made quite trivial by Compose, because all you need to do in order to share bits and pieces of UI is to create a file or an Android library that just contains a bunch of composable functions are the composable functions that you use throughout your application. You could then take this file or library and use it subsequently in another application. Another great thing about Compose that I know and have encountered is that it's relatively easy to switch between Compose and Swift UI. As someone who's also dabbled in a little bit of Swift UI development, moving between Compose and Swift UI, making that context shift is quite inexpensive. Most of the concepts and syntax used by both these frameworks is very, very similar. Very, very familiar when moving between both of them. However, one of the downsides that Compose does exhibit currently in its current version, which is 1.1.1, is that there are still very, very many experimental APIs packaged into the framework in library. Of course, over time that this will be rectified by Google as the APIs mature and as Compose matures as a framework for defining UI. But in the meantime, in order to utilize experimental APIs, it does require that you add additional annotations to any functions that are consuming or using experimental APIs, which isn't great from a readability perspective, but doesn't cause too many problems. So to conclude, Jetpack Compose is most definitely the future of native UI development for Android. Compose accelerates Android app development, and thus developers can deliver applications in a much more timely manner with a lot less work. Declarative frameworks are gaining in popularity. We see this in Swift UI and the popularity of Swift UI, React, etc. Declarative frameworks will probably be around for quite some time, many years to come, and will be used for perhaps even longer than that for developing UI views. Compose solves many of the problems inherent in the view system and XML layouts. Compose is well supported. Google has provided an excellent plethora of documentation for Compose, especially for new developers. The view and XML layouts will continue to be supported, but new apps should use the Jetpack Compose system for defining their UI, unless, of course, your client has a specification or requirement that a more mature UI system be used. New Android devs, I would encourage, should still learn the XML layouts and the view system, because likely going into the future, there's going to be many, many large legacy applications that will continue to utilize and implement XML layouts. And so knowing a little bit, at least a little bit about XML layouts will probably help you in your future career if you so choose to become an Android developer or to develop Android applications. So in this particular slide are a bunch of useful links that I found and used for preparing this presentation, notably the Jetpack Compose documentation, some reasons why to adopt Compose over XML and the view system, a link to the Jetpack libraries and everything that the Jetpack has to offer in terms of libraries and tooling for Android developers. Of course, the tooling that Compose comes bundled with. A little bit more about XML layouts and how you define XML layouts to define views of Android application, and a link to the Kotlin standard library. So with that, I open it up to the audience. Does anyone have any questions?